This module is called Archiving Files. In order to understand what archiving is, let's have a look at some of the tasks that we might need to perform on a collection of files or subdirectories. So imagine that you have a directory somewhere, and in it you can have a collection of files and maybe some subdirectories as well, and you want to perform some actions on all of those files and subdirectories as a unit. Not just as a collection of 100 different files, but as one block, as one unit, as one entity. What might you wish to perform? Well, you might want to move them or copy them to another location on the hard disk. In other words, you might want to duplicate the entire branch, the entire directory tree that you're in. You might want to back them up onto some removable media, such as a tape or a disk. And finally, you might want to send them somewhere electronically, maybe via email, maybe via FTP or something, to another machine. All of them as a unit, not individually. Now, in Windows, I don't know if any of you are familiar with Windows, but there is a familiar concept in Windows that is the zip file. If you're ever used to using WinZip or PKZip files in general, then you'll be hopefully familiar with this concept. What we're talking about is bundling a great bunch of files and directories together and putting them all into one file. Although it doesn't actually have to be a single file. An archive is either a single file or it is an image on tape or disk that represents all of the files and directories that you have decided to treat as a unit. You'll be storing in that file or in that image the file names, their ownerships, their modification dates, and, of course, their contents. All that information will be stored in a single place, in a single file or on tape or disk as an image. There's a variety of programs that we have available in Unix to do exactly this sort of thing, and let's have a look at some of those. I will just briefly give you some demonstrations of some of these programs: tar, CPIO, gzip and compress. These are all programs that we use in the process of archiving. In the table there I've shown you which ones we can use to write data out to an offline media like a tape drive or a floppy drive, and those ones are tar and CPIO. We also can see which one of them provide compression, in other words tar, gzip and the program of course called compress. Let's have a look at those in turn. Now, don't forget, of course, that all of these you can look up the manual page to find more information on them. I'll start with a very simple operation using tar. I'm going to gather up all the files and directories and subdirectories in the course directory and treat them as one tar file. Note that this will make a duplicate of the files within the archive. The original files will not be touched. So I say, alright, I'm going to go tar and I'm going to use the C option. Interestingly, there's no minus sign before the options in tar. Tar C F, and the F means I'm going to now specify the name of the file that I want to put them into. So I'm going to put them all into a single file and I'm going to call it files.tar. I don't have to put the .tar extension on the end of it. I could just call them files. In fact, I will, just to prove that I can. So I'm going to gather all of these files up and I'm going to put them in a file called files. And what am I going to put in there? Well, I'm going to put the current directory, everything in the current directory, including all subfolders. So I press enter. And I get a message saying that it's actually not going to put itself into itself. It's not going to put files into the archive called files, which is fairly reasonable. And that's not really an error message, that's just a little notification. So now I can do a listing. I might do an ls-l and find that there is in fact a file here called files, and it is 368,000 bytes, 368K. So it's pretty fair to say that it's probably got every single file, all these other files, bundled up inside it. I can now move or copy this file somewhere else, and then I can use another tar command. Instead of using the tar-c for creating an archive, I can use x for extract from an archive. So I could simply say tar xf files, and it would extract the entire contents of files into wherever I happen to be. So I would probably take the files file. Please don't get confused. There's a file called files, and if I took that to some other directory and I used the command that you can see at the bottom on that, tar xf files, it would extract everything inside the archive into the empty directory in which I happen to be sitting. And the archive itself would remain untouched. It would still be 368,000 bytes. The files would not be removed from the archive, they would just be extracted, or duplicated if you like, from the archive. Anyway, that's how tar works. CPIO is somewhat similar. CPIO is probably the, if you like, the industrial strength version of tar. It's trickier to use. The options are far less intuitive, but it is far more thorough. Now, I'm not saying that tar will accidentally skip a file or something, but with CPIO you're capable of specifying far more detailed options. But I don't want to go into it too much because the concepts are virtually the same, and you can look these up in the manual pages. Just the usage of CPIO is a little different, so I'll show you how it's used. You type in find, and then the name of the directory in which you want to take the files from, and then the criteria that you want to use to extract the files. So I might say -name star.txt or something, and then I use the pipe symbol, which we're going to learn about in a later chapter, and I pipe them to CPIO -o, and then I can send the output, that's what the little O stands for, output the data to either some kind of file, we'll call it files.cpio to let us know that it's actually a CPIO file. So we could store them in a file, everything, or alternatively we could store them in a device like tape 0. That is a device file. You don't know what a device file is yet, but it is possible using a command very similar to that, and it's going to differ from Unix to Unix. Everybody's device files are different. It's possible using a command like that to write the contents of all those files out onto magnetic tape. Or you could even use floppy disk if you typed in /dev/fd0 if your Unix system happened to have a floppy disk. That's essentially how it works. To read information from that CPIO archive, you would simply do this, CPIO -I, and then you would read from /dev/fd0. Again, you're going to learn about what this little less than sign means and what the greater than sign means from the last example. For now, I just want to show you the usage of the program. The -I stands for input, whereas in the previous example it stood for output. So this is the opposite. So that's CPIO. Now, if you decide to create an archive file as opposed to putting an image onto a tape or floppy disk, and you plan to do something with that file, like transmit it across the internet, you might want to think about reducing the size of that file. We're talking about something like compression. There's a bit of magic that you can do to a file which will compress it into a smaller file. It might be a half of the original size, or it might even be less. Now, the file is not usable in its compressed format, but at the other end, wherever that other end happens to be, whenever you actually do want to use the file, you can simply uncompress it using the same program, and then you have full usage of the file again. So you could compress one of these tar files or CPIO files. And I'll show you an example of that. We could simply do compress files like that. And it's done. Let's have a little look at our directory listing now. Look at what's happened to files. It has got a .Z or capital Z extension on it. Let's do a long listing, a ls-l, and we'll find that instead of 368,000 bytes, files.z is 152,000 bytes. So it is less than half the size. Now that it is compressed, we can then transmit it wherever it needs to go much faster. Or if we need to back it up onto some medium like floppy disk or tape, it will take up less space. Once we get it to the other end, or we're ready to use it again, we can say uncompress files.z, and we end up with the full 368,000 bytes again, and we're ready to use files, which means, of course, in this case, that we would untar it, or use the tar X option. Well, that's all I'm going to say about archiving and compression.